Alright, this video is on exponential growth and decay. Alright, so exponential growth occurs when a quantity increases by the same rate over time. And the equation is y equals a times the quantity 1 plus r raised to the t power. Alright, a stands for the original amount, just like we had a to the first in our geometric series or sequence. A stands for your original amount. R stands for your rate, and we're going to write it as a decimal. And then T is your time, usually in years. Alright, so example 1. The original value of an investment is $1,400, and the value increases by 9% each year. Write an exponential growth function to model this situation. Then find the value of the investment after 25 years. Alright, so A, my original term is 1,400. My rate is 9%, which as a decimal is 0.09. Okay, so you have to move it 2 places because 100 has 2 zeros. So you move it 2 places to the left. And then my time is 25. So I'm going to plug it into my formula. Y equals A. Well, A is 1,400 times 1 plus R. R is 0.09 and T is 25. So that's what my formula looks like. Then I'm going to do, please excuse my dear Aunt Sally, I have to follow order of operations. So 1 plus 0.09 would be 1.09. And then I have to do exponents before I can multiply. So I'm going to do 1.09 to the 25th power. Now remember, you have to use your calculator. Okay, I don't expect you to do 1.09 25 times. Okay, so on your calculator you have a button that either is a little caret symbol, or x to the y, or y to the x, something like that. So you would press 1.09 x to the y 25 equals, and then multiply it by 1,400, and you get $25,000 or $25,072.31. All right. The next problem. The cost of tuition at college is $12,000, and it is increasing at a rate of 6% each year. Write an exponential growth function to model the situation, then find the tuition cost after 4 years. So I'm going to plug it into my formula. A is 12,000. My rate was 6%, so 0.06, and my time is 4 years. So 1 plus 0.06 is 1.06. Raised to the 4th power, 1.06 to the 4th power times 12,000 gives me $15,149.72. The number of student athletes at a local high school is 300 and increasing at a rate of 8% per year. Write an exponential growth function to model the situation, then find the number of student athletes after 5 years. So I'm going to plug it into my formula. My starting value, my original amount, was 300. My rate is 8%, and my time is 5 years. Work inside the parentheses first, raise it to the 5th power, multiply it by 300, and I get 441 athletes. Annual sales for a company are $149,999 and are increasing at a rate of 6% per year. Write an exponential growth function to model the situation, then find the annual sales after 7 years. So I'm going to plug it into my formula. That's what it looks like. Work inside the parentheses, add, raise it to the 7th power, then multiply it by 149,999, and I get $225,543.04. The population of a small town is 1,600, and it's increasing at a rate of 3% per year. With an write an exponential function to model the situation, then find the population of the town after 10 years. Plug it into my function. My original amount was 1,600. My rate is 0.03, and my time is 10 years. Add, raise to the 10th power, multiply by 1,600. We get 2,150, and this is dealing with people, population. And number 6. In 1985, there were 285 cell phone subscribers in Mayville. The number of subscribers increased by 75% per year after 1985. How many subscribers were in Mayville in 2008? Okay, so my original value was 285. My percent is 75, so 0.75. And then the years, I have to figure out how many years there were between 1985 and 2008. So there was 23 years, so that's where the time came from. Work inside the parentheses, raise it to the 23rd power, multiply it by 285, and we get 110,845,988 subscribers. Alright, exponential decay occurs when a quantity decreases by the same rate over time. A still stands for the original amount, R still stands for the rate in decimal, and time still stands for, or T still stands for time in years. The only difference in your equation, instead of plus, we're subtracting the rate, 1 minus the rate, raised to the T power. Alright, the population of a town is decreasing, keyword, at a rate of 1% per year. In 2000, there were 1,300 people. Write an exponential decay function to model the situation, then find the population in 2008. Okay, so my original amount was 1,300. My rate is 1%. And my time is the number of years from 2000 to 2008. Okay, so 1,300 is A, 0.01 is R, and 8 is T. 1 minus 0.01 gives me 0.99. Raised to the 8th power, and then multiply by 1,300, I get 1,200 people. The value of a car is $18,000 and depreciating, that means going down, at a rate of 12% per year. Write an exponential decay function to model the situation, then find the value of the car after 10 years. Plug it into my function. My original amount was 18,000. My rate was 12%, and my time is 10 years. 1 minus 0.12 is 0.88. Raised to the 10th power times 18,000, I get $5,013.02. A farmer buys a tractor for $50,000. If the tractor depreciates 10% per year, write an exponential function to find the value of the tractor in 7 years. The original amount was $50,000. The rate of depreciation is 10%, and the time is 7 years. 1 minus 0.10 is 0.9, raised to the 7th power, times 50,000, gives me $23,914.85. So that would be the value of the tractor after 7 years. Number 10, an investment of $8,200 loses value at a rate of 2% per year. Write an exponential decay function to find the value of the investment after 9 years. Plug it in, subtract, raise it to a power, we get $6,836.73. The value of a book is $58 and decreasing at a rate of 7% per year. Write an exponential decay function and find the value of the book after 8 years. Alright, so my original amount was 58, my rate is 7%, so 0.07, and my time is 8. Subtract, I get 0.93, raise it to the 8th power, and then multiply by 58, I get $32.46. Alright, number 12, the population of Haywardsville is decreasing at a rate of 2.5% per year. If the population in 2000 is 28,000, what will be the expected population in 2015 if the rate of decrease continues? Okay, so my original amount was 28,000. My rate is 2.5, so when I move the decimal 2 places, I get 0.025. And then the time from 2000 to 2015 is 15 years. So 1 minus 0.025 is 0.975. Raise that to the 15th power and multiply it by 28,000. We get 19,153 people.